Hello viewers, I'm here on the YouTube channel PK Pachala and I'm bringing you the new topic, that is climate change, evidences, impacts and problems of discourses. So in the very beginning, let us see, there is a picture in the first slide of my presentation, and if we see it very closely, we will see certain things, that the sun, the atmosphere, the oceans, clouds, the hydrological cycle, the ice and snow, land surface, streams, rivers, and above all, the human influences. So, all these are the components of a certain system, and that system is climate system. And if you look at this, it's a very vast. If you consider the climate change as a subject, the subject matter of this subject is very vast. If you consider it as a discourse or a science, it's very complex. And if you consider it as an issue, then the issue is very multidimensional. Why it is called multidimensional? That already I have mentioned, that the complexity of the system, that the climate change, it involves lot of things. The first is that already I mentioned here, that the sun, atmosphere, the oceans, the hydrological cycle, then clouds, ice and snow, land surface, rivers and streams, vegetation cover, and finally the human being. As we are living in the earth, we are the part of this system, and in this system there are lots of elements which are very complexly interlinked to each other, and the climate change phenomena also depends upon each and every elements, how the elements are changing over time, and depending upon that, the climate also reacts. In the introductory part, let us see what is climate change. Climate change has been happening since the time immemorial, but now climate change is a great concern all over the world. This is one of the biggest challenges to the global community living on the earth. If climate change is a phenomenon which is happening since the time immemorial, then there is an obvious question, and that question is, why is it a matter of worry? Why is it a matter of great concern? The real thing is that the rate of climate change has increased manifold in recent few years, especially after the Industrial Revolution. It's a never-ending endeavor by humans as the population pressure, urbanization, deforestation, industrialization, luxurious standard of living are rampant in their only and one homeland, that is the earth, as they're accelerating the pace of global climate change. Despite of this, it's a matter of fact that population has to increase. It may be in the slowest rate ever in the demographic history of the world, but of course population will rise. There is no doubt about it. They will be urbanized and luxurious. Now question is that, are the humans capable of controlling the emission of harmful gases such as chlorofluorocarbons, carbon dioxide, carbon monoxide, sulfur dioxide, etc., which lead to climate change? Are the humans able to increase the vegetation cover of the globe? These are the certain questions which need to be asked. Are the humans capable of sustainable industrialization and urbanization? These are the real challenges in near future before us as the sensible people of the 21st century on this earth. Now, let us see the definition of climate change. There are lots of agencies all over the globe who are involved in the discourse of climate change. And the first definition that I want to forward here, that is by the IPCC. The climate change in IPCC ages refers to a change in the state of the climate that can be identified, for example, using statistical tests. The statistical tests such as the parametric or the non-parametric test, by changes in the mean and or the variability of its properties, and that persist for an extended period, typically decades or longer. It refers to any change in climate over time, whether due to natural variability or as a result of human activity. This usage differs from that in the United Nations Framework Convention on Climate Change, which is simply known as UNFCCC, where climate change refers to a change of climate that is attributed directly or indirectly to human activity that alters the composition of the globe atmosphere, and that is in addition to natural climate variability observed over comparable time period. Now, let us see the another definition of climate change. That climate change can be defined as a measurable shift in climate, such as marked changes in mean temperature or rainfall, or altered pattern of extreme weather involving storms, floods, or droughts. Such shifts are usually measured against known climate benchmarks averaged over a long period of time, typically 30 years. For example, 1930 to 60, 1961 to 90, and so on. Climate change persists for years or longer and can occur at any special scale. When widespread, affecting large regions such as the whole countries and the continents, it becomes a major event. So, there are two schools of thought. The first school of thought, they are in favor of the climate change. That means, according to the first school of thought, there is a phenomena which is called the climate change. That means the climate change is happening. And there is another school of thought. And according to the second school of thought, there is no climate change. According to them, climate change is a global politics. Climate change is a global data politics. But despite of the controversies between these two school of thoughts, we have certain evidences, and that evidences show us that there is certain thing and that is happening, and which is remarkably observable in the global surfaces. Now, let us see some example of these evidences. The first one is O'Higgins Glacier melt that is located in Chile of South America. On the left hand side, this picture or this satellite imagery from 1973 shows certain areas are covered by snow or ice, and there is a glacier which is flowing down the slope. Now let us see the same glacier or the same area covered by snow and ice looks like something different in 2007. So what the basic difference we can see or we can observe from these two different photographs of the same region, that this purple color mark indicates that there is a significant recession of this glacier. That means the length of the glacier in 1973 and the length of the glacier, the same glacier in 2007, is quite lesser than the earlier period. So the another example that we can take from Uganda and the Democratic Republic of Congo, Stanley and Baker peaks have been diminishing, as is evident in these images, in these two images. I'm going to show here that they shrunk by half between 1987 and 2003. The first image that was taken in 1987 is look like something this, and the next image this look like something this, and this image was taken in 2003. So the comparison of both the images shows that there is a significant decrease of ice or snow, especially this bordering region of Uganda and Democratic Republic of Congo, where the Stanley and Baker peaks are locating. This arrow marks clearly indicating the recession of the snow and ice. Now let us see the Bear Glacier of Alaska, the famous glacier, one of the famous glaciers of Alaska. It is a clear indication of increasing temperature in the higher altitude, which marks the global climate change. Warming in the region has caused less buildup of snow and therefore less material for glacial growth. As the glacier has receded, ice at the end of the glacier has broken out the main body, forming icebergs in the ocean water. So from these two images, the left hand side image of Landsat 3 was taken in 1980, and the right hand side image, that is Landsat 4 image, was taken in 1989. So as compared to the 1980, in 1989 the thickness of the snow was less, and that is why it was broken in parts and it was floating in the oceanic water as icebergs, which is clearly seen from the right hand side image that was taken in 1989. Now let us see the another condition, that is from 2011. It is an image of Landsat 7. The 1980 and now 2011, there is a remarkable sense in the glacier that it has shown the clear cut receding of the Bear Glacier, increasing number of icebergs in the oceanic water. Now let us observe certain kind of things which are happening in the Arctic sea ice. The Arctic sea ice has been decreasing over the decades, and this is the graph representing the diminishing or the vanishing Arctic sea ice starting from 1980 to 2013. So though the graph fluctuates sometime high, sometime low, sometime high, sometime low, the average gradient is declining. That means the ice or the snow covered region of Arctic Sea is completely in a decline trend. An interesting fact is that as compared to the 1980 and in 2010, especially after 2010, that is the year in 2012, which recorded the highest melt, especially during the summer. So during the summer period or the summer season of 2012, huge amount of ice or snow were melted from the Arctic Sea. Now let us take another example of receding snow or glaciers. The glacier of the Arctic region has been fluctuating over the years. If we compare, there is a clear indication of shrinking glacier. The Greenland and Antarctic ice sheets have decreased in mass. It says that the climate all over the globe has been changing. So here is one short video that taken from NASA, and that clearly indicates certain kind of fluctuations of ice or glaciers of Arctic as well as the Greenland region. Now let us have a closer look of this scenario, how it looks like. From 1980, then 1985, then 1990, then 1995, then 2000, 2005 and 2010. If we see and if we allow it to play automatically, we can see the fluctuations of glaciers and ice that develop, especially in the Arctic region and in the northern part of Greenland. So sometime a huge amount of glaciers or ice covers we can see, and sometime the glaciers and ice covers is very much minimal. So this short video clearly indicates that there is certain kind of thing happening, that is the shrinking of glaciers. So shrinking of glaciers means it clearly indicates that there must be some kind of thing that happen in the atmosphere, that is temperature. So ice and temperature, it has inverse relationship. If temperature increases, the ice or the glacier will decrease. If temperature decreases, then there will be more ice formation and consequently more glaciers. Now, very unfortunately, we have already seen the decreasing glaciers and snow covered areas of the world. It indicates that the average temperature of the atmosphere is slowly or rapidly increasing depending upon the sequences of time. On the other hand, it's very unfortunate for the mankind in the earth that the number of trees or the vegetation cover of the world is decreasing. So here is one table, the estimates of forest area, net changes in forest area and carbon stock in living biomass in 1990 to 2000 and then 2005. So the global forest cover is the largest carbon stock next to the oceans. So directly or indirectly, we human beings are dependent on the vegetative cover of the globe. So the increase and decrease, it has direct impact on the human society. If the forest cover or the greenery of the global surface increase, it indicates certain positive symptoms. And if it decrease, that means there will be less carbon stock in the vegetative cover, which is very harmful for the human society. Now let us see Africa, the continent, had 632.412 million hectares of forest area during 2005, which has decreased by 4.4 million hectare per year in 1990 to 2000, and then 4 million hectare per year during 2000 to 2005. Whereas the carbon stock in living biomass, that is in metric ton, was 2,41,267 during the year 1990, which reduced to 2,28,067 in 2002. Further, in 2005, it decreased to 2,22,933. On the other hand, let us see the condition or the status of our continent, that is Asia. The total forest cover area was 571.577 million hectare, and it was reduced by 0.8 million hectare per year during the time period of 1990 to 2000. And very unfortunately, during the year 2000 to 2005, the annual change of forest cover was 1 million hectare per year. And now see the carbon stock in living biomass, that was 1,50,700 metric ton, which reduced to 1,30,533. Again, it reduced to 1,19,533 the year of 2005. Now see the forest cover area of Europe was 1,001.394 million hectare during 2005, and annual change rate was plus 0.9 million hectare per year, which is a very good sign during the year 1990 to 2000. But during 2000 to 2005, obviously there was a less rate of increase of global forest cover, especially in the European region. And during 2000 to 2005, the annual change of forest cover was positive, that was 0.7 million per hectare per year. Now the carbon stock was 1,54,000 during the year 1990, which increased up to 1,58,033 during 2000 and 1,60,967 during the year 2005. This is a very good symbol. Now let us see North and Central American condition. The forest cover was 705.849 million hectare, which reduced, means the annual change rate was 0.3 million hectare per year during 1990 to 2000. Again in 2002 to 2005, the annual change of forest cover was negative during 2000 to 2005, that was 0.3 million hectare per year. On the other hand, the carbon stock was 1,50,333 metric tons in 1990, then 2000, and the year of 2000 it was 1,53,633, then 2005 it was 1,55,467. Now see the entire condition or the status of Oceania. The total the forest area was 206.254 million hectare, which reduced by 0.4 million hectare per year during 1990 to 2000. Then 2000 to 2005 it remained same, that 0.4 million hectare per year. That is the declining trend. Again the carbon stock was 42,533 metric ton, then in 1990, then 2000, and the year of 2000 41,800 metric ton, then during that year 2005 it remains same, that is 41,800 metric ton. Now see the status of South America. The forest area was 8,31,540 million hectare, which is huge as compared to the other continents of the world. But unfortunately during 1990 to 2000 the annual change rate was negative, that is 3.8 million hectare per year, which further changed to 4.3 million hectare per year. Then let us see the carbon stock. Carbon stock was 3,58,233 metric ton, which further reduced to 3,45,400 metric ton during 2000, and in 2005 it reduced up to 3,35,500 metric ton. Now let us see the world status. The total forest area all over the globe is 3,952,026 million hectare. During 1990 to 2000 the annual change rate is again negative, that is 8.9, and in 2002 to 2005 the annual change rate is 7.3, which is negative and not a good symptom for us. And the carbon stock all over the globe, that is 1,097,067 metric ton, which reduced to 1057467, then again further reduced to 1036200 during the year 2005. Now let us see the change in global forest cover, how it looks like in a pictorial form or in a map form. The net change in forest area between 2000 and 2005, and this is look like something like this. This is look very dangerous for the mankind. The red color indicates that more than 0.5% decrease per year. These are the reasons. And now let us see the deep green color indicates where the change rate is in positive, that is more than 5% increase per year. And the last one is the unchanged, or we can say it change that is more than 0.5% per year. Now let us see the trend of atmospheric carbon dioxide. So this is one graph, and this graph based on the comparison of atmospheric samples contained in ice cores and more recent direct measurements provides evidence that atmospheric carbon dioxide has increased since the Industrial Revolution. Now clearly we can see it here, the increasing trend of atmospheric carbon dioxide, and humans have the largest contribution of carbon dioxide by their different activities, burning fuels, flying vehicles, cutting down the forests, and whatever we do, basically we release carbon dioxide to the atmosphere. And this is how the concentration of the carbon dioxide in the atmosphere is increasing, and on the other hand, the vegetative cover of the globe is decreasing. Now let us see that already we have told, or we have seen, that climate change is a very vast discourse, or if we consider it is an issue, then it is a multi-dimensional issue. But main thing is that to study about the climate change phenomena, to study about the climate change, there are lots of challenges. And let us see. A mere talking about climate change is so easy, but the realization of real facts comes from scientific studies, which need various databases across the globe in temporal resolution and their systematic statistical analysis. Just simply we can't say that this is because of climate change, this is climate change. To prove it, we need sufficient database in our hand, and those database we need to analyze scientifically in a statistical method, and after that only we can say that climate change is a real fact. But the real challenge ahead of the global scientific community is that the shortage of relevant data, especially in the third world countries. We have three different categories of countries: the developed countries like US, most countries of the Europe, and Japan from Asia. Then the developing countries like India, Brazil, China, and there are another category of countries, that is the underdeveloped countries or the third world countries. And very unfortunately, the number of undeveloped countries in the world is highest. And we the student, or we the people, or the scholar, those who want to study about climate change, who deals with the issue of climate change, they have one big challenge in front of them, that is the data shortage. And the data shortage especially is in the developing and underdeveloped countries, and especially the underdeveloped countries, there is a huge shortage of data to study about the climate change. So some of the problems of scientific study about climate change are highlighted here, taking from the synthesis report on climate change 2007 of IPCC. Now let us first see the first thing. Climate data coverage remains limited in some regions, and there is a notable lack of geographic balance in data and literature on observed changes in natural and managed systems, with marked scarcity in developing countries. Second thing, analyzing and monitoring changes in extreme events including drought, tropical cyclones, extreme temperatures, and the frequency and intensity of precipitation is more difficult than for climatic averages, as longer data time series of higher spatial and temporal resolutions are required. Now, effects of climate changes on human and some natural systems are difficult to detect due to adaptation and non-climatic drivers. Now what we can understand here, that effect of climate change on human, we human being have the adaptability, we can adapt with a certain environment or a certain climatic condition. So this is one of the thing due to which it is very difficult to speak on that. And on the other hand, the natural system is a very complex one. So the adaptability or the adaptability condition of human, on the other hand, the complexities of the nature makes it very difficult to prove that the climatic change or the climate change is a fact. Now see, difficulties remain in reliably simulating and attributing observed temperature changes to natural or human causes at smaller than continental scales. At these smaller scales, factors such as land use change and pollution also complicate the detection of anthropogenic warming influence on physical and biological systems. If we consider climate change as a complex system, so there are certain lot of systems in the earth, the physical systems, the biological systems, and if we see, there are so many local things such as the land use, land cover changes, the pollution, the local pollution level of river, water, land, soil, then the air, and it make very complicated to detect the warming condition of the environment or warming condition of the atmosphere only because of certain kind of anthropogenic activities. Because there are certain phenomena in the nature itself which are also involved in increasing temperature of the globe. The magnitude of carbon dioxide emissions from land use change and chlorofluorocarbons emissions from individual sources remain as key uncertainties. There is another challenge in front of the climate change scientists, that is the magnitude of carbon dioxide emissions from land use change and chlorofluorocarbons emissions from individual sources are not certain, rather it is very uncertain. And these are the certain problems that we already talked about. To study about the climate change, to address the climate change issue, we need to have, or we need to facilitate those things to overcome the problems of climate change discourses or climate change studies. First thing is that we need to have sufficient data, not only for a certain pockets of the world, but all over the world. We need uniform data, and here I conclude. Thank you. ভূগোল বিজ্ঞানৰ শাখা, য'ত পৃথিৱীখনক মানুহৰ আৱাসস্থল হিচাপে ধৰি লৈ পৃথিৱীখনৰ বিষয়ে অধ্যয়ন কৰে, আৰু লগতে মানুহ আৰু মানুহৰ বসবাস কৰা এই যে পৃথিৱীখনৰ সম্পৰ্ক, সেই সম্পৰ্কৰ বিষয়েও আলোচনা কৰে। গতিকে আজিলৈ ইমানে। মই ইয়াৰ পৰৱৰ্তী পৰ্যায়ত মানৱ ভূগোলৰ আৰু বিশেষ অধ্যায় লৈ এনেদৰে উপস্থাপন কৰিবৰ চেষ্টা কৰিম। আজিলৈ ইমানতে সামৰণি মাৰিছোঁ। ধন্যবাদ।